Hello everyone, my name is Ariana Yesca from section A03, and I will be talking about SEMG analysis of back muscles during loading. The exact name of the study is Reliability of SEMG Data of Back Muscles During Static Maxial Loading Situations, Values and Pitfalls. It's from 2024, and the goal was to examine reliable surface electromyography for measuring activity of key back muscles and under controlled static loads. As you can see on the image to the side, they used that machine in order to create the static loads. Some research questions are: would similar reliability be observed during dynamic conditions rather than static tilts? And could alternative normalization techniques improve reliability without reducing ICC values? Also, how stable are these measures across longer follow-up periods beyond 14 days? Context, the follow-up period was 14 days. So we're going to do a CARP article evaluation. So the currency is pretty okay because it's from 2024 from the Journal of Electromyography and Kinesiology. It also references a lot of updated consensus standards which were used in the study. So we have the first author, Lena Madier. She is under the Division of Motor Research, Pathophysiology and Biomechanics, Experimental Trauma Surgery, Department of Hand, Reconstructive and Trauma Surgery from the Jena University Hospital in Germany. And also there was a lot of adherence to ethical protocols such as the Helsinki Declaration and other standards. It's pretty accurate in the sense that it is peer-reviewed by a reputable journal, and there's also a lot of clear inclusion and exclusion criteria, controlled experimental setup, which was the sensor device that they used. They were also very specific with the electrode placement, following the CENIUM guidelines, and they used appropriate statistical methods. It was very relevant for biomechanics and physical therapy specifically. All of these, which used repeated SEMG measures to track muscle performance or also to diagnose. The only problem is that these findings are limited to healthy adults in the 25 to 55 range. So the purpose of the article is that the study demonstrated that SEMG, if in back muscles, was actually reliable and when using raw amplitude values. Clinically, this means that SEMG can be used with more confidence when you are evaluating back muscle activity. And the methods are also clearly described and therefore it can be repeated. So the participants were 49 adults, 24 women, 25 men, all of them in between 25 to 55 years old. They used the inclusion criteria of BMI under 28, height under 190. The only reason for this is the device of the centaur device limits. There had to be no acute back pain or any spinal surgery, and no orthopedic abnormalities. For approval, they were all approved by the Ethics Committee of Friedrich Schiller University Jena, and they conducted under the Helsinki Declaration, and all of the participants provided written consent. For the measurements, they used the ilocostalis, the multifidus, and the longissimus, also known as the erector spinae. And they used the CENIUM guidelines, as mentioned before, in the electrode placement. And the signal acquisition was an amplification times 1000 with an input impedance of 1200 and a noise under 1 mu volts. So the sampling rate was 2048 hertz with a 24-bit resolution, and the bandpass filter was 10 to 350 hertz. The CENIUM guidelines, to get an idea of where the electrode placement was for each of them, you can see the blue marks for each of the muscles that they were identifying. So the strengths is that everything was controlled. There was a good sample size, and they used multiple reliability metrics. The main limitation is the population scope being only 25 to 55, and the fact that the loads were only statics, and that we only got data from the left side. So they used the Shapiro-Wilk test to check if the data was normally distributed. Then they did the Wilksagon signed rank test to compare measurements between the two sessions. They also used the effect size to quantify magnitude of differences across conditions. And the interclass correlation coefficient, the ICC, which was mentioned before, is to assess the retest reliability of the SEMG measures. And they use the standard error and of measurement and of mean, and the coefficient of variation of method errors to quantify systematic error relative to the mean values. So the results were that the RMS values were very reliable, with the ICCs mostly above 0.7, and at the MF, the LO showed higher reliability than the ICO, and the standard error of mean and were increased with load, but the systematic error stayed pretty much the same. And for the normalized values, the reliability was much lower, with ICCs often below 0.7. Authors explained this drop was due to reduced inter-individual variance. And for reference ranges, they used normative values, which were established and can serve as diagnostic benchmarks. For the interpretations of the author is that we got that the main conclusion was that RMS amplitude values are reliable for SEMG of bat muscles during submaxial static loads, and that the normalized data had lower ICCs, and this reflects more of like the intended reduction of variance caused by normalization and didn't really signify any poor reliability. And they also came with the practical recommendation that researchers should rely on original and non-normalized values for reliability assessments whenever available. Thank you.